I'm Lauren and I'm going to introduce question number 3A part 3. The sales amount of invoice of a certain company is normally distributed with a mean of 15,000 and a standard deviation of 5,000. If a random sample of 25 invoice is selected, what's the probability that the total amount of sample is less than 256,000? For P, the total amount is 256,000, which we got the X less than 256,000 over 25. And we have probability X less than 10,240. Then the probability is Z less than bracket 10,240 minus 15,000 over 1,000. So we have the probability Z less than minus 4.76, and we got the answer very close to 0.
Hello, I'm Charlie. For question 4A part 1, Mr. Wang is the sales manager for a confectionery manufacturer. In a survey of a random sample of 200 outlets in northern China, he found that 50 of them would be willing to stock a proposed new product. Find a 95% confidence interval for the population proportion of outlets in northern China which will stock this new product. So for the first step, let P be the proportion of outlets in northern China which will stock the new product. N is the sample size, which is 200, and P hat equals to the proportion, which is 50 over 200, and it is 0.25. A 95% confidence interval for the true proportion of outlets which will stock the new product. 1 minus alpha equals to 95%, alpha equals to 0.05, Q equals to 1 minus P hat, and therefore Q is 0.75. And the formula for the population proportion is P hat plus and minus Z with base alpha over 2 and a square root of P times Q over N. So we will have the formula of 0.25 plus and minus Z with base 0.025 and a square root of 0.25 times 0.75 over 200. And by looking at the standard normal distribution graph, we will know that Z with base 0.025 is 1.96. So the final answer is P less than 0.3100 and larger than 0.1899.
Hello, I'm Mickey. I'm going to discuss mock 1 question 4A part 2. Mr. Wang intends to conduct a similar survey in southern China. He wishes to obtain a points estimate of the population proportion of outlets willing to stock the new product in southern China. How large a sample size should be used if he wants to be at least 95% confident that his error of estimates does not exceed 0.04. 95% confidence interval is equal to alpha, and alpha is equal to 5%, which is 0.05. And we are going to use the equation of x bar plus and minus standard score of 0.025 square root PQ over N, and 0.025 is calculated from alpha over 2. And in this question, the error is standard score of 0.025 square root PQ over N. And firstly, we need to find out PQ. As Q is equal to 1 minus P, so we can use the computing square to find out the maximum value of PQ. And after using the equation of computing square, we can find that 1 over 4 is the maximum value of PQ. So we can take PQ equals to 1 over 4. And according to the table of the standard normal distribution, when Z is equals to 1.96, the area is 0.025. So we can find that the Z 0.025 is equals to 1.96. And according to the question, he wants to find out his error of estimate does not exceed 0.04. So that means we need to find the error which is smaller than 0.04. So the equation is found out. The equation is occurred. 1.96 square root PQ over N smaller than 0.04. And we can substitute the PQ as 0.25. So we can find out N is larger than 600.25. And the final result is N equals to 601, which is round up magnitude. Thank you.
Hello, I'm Dixon. Today I'm going to talk about question 1D. Construct a 99% confidence interval for the mean percentage of revenue spent by all computer software companies on research and development. State the assumption and approximation. So we can see that 99% is the confidence interval, and 1 minus 99% confidence interval will be the alpha, which is 1%. Bar X is the normal distribution, and the sample size is equals to 50, which is larger than 30, suitable to the law of central limit theorem. SD is already known, so we are going to use the formula of standardish normal distribution. So the SD here is 1.73698, and the bar X equals to 8.354. Alpha is equals to 1%, and the sample size is 50. By using the equation bar X plus or minus of standard normal distribution, alpha divided by 2 times SD over square root of the sample size. And according to the standardized normal distribution, 0.005 is equals to 2.575. And after substitute all the number to the equation, and after the calculation, we will get mu have to be larger than 7.72% and smaller than 8.99%.
Hi guys, I'm Oscar, and today I'm going to present the question number 3D with Tony. And the question shows that the daily revenue of a boutique is normally distribution with a mean of 10,000 and a standard deviation of 2,000. Assume that the boutique works 7 days a week. What is the probability that there are 2 weeks in 4 non-overlapping weeks that the average daily revenue of the boutique is between 8,500 and 12,000?
Hi, it's Tony. Let's decode these questions. First of all, we should think about what kind of distribution it is. It's just simply put normal distributions. in sampling or other distributions. From the questions, where it is not talking about the samples, the probability of the sample, the whole sample happen in a particular range. Rather, it is talking about part of the sample happen in the range required. Therefore, it will become too complicated just using normal distribution to calculate this question. However, when we think it in other perspective, like thinking the probability happen in the range required as successes, not in this range as failure, this question will be more easy to solve. Using normal distribution in this question, we have to think about what is the N and P in normal distributions. N should be the 4 weeks, and P, we have no idea, so we have to calculate. The P refers to the probability of successes. We could using normal distribution to calculate it. As from the questions, since we are finding the number of 2 weeks out of 4 weeks happen in the range required. Therefore, when we are applying normal distribution to calculate the probability of successes, we are going to find the probability of 1 weeks happen in this range, which refers to 7 days given in the questions. Therefore, when we're using sample distributions, N will be the number of 7s, and just simply input all the data to the formula. Then you will calculate the probability of successes happens in 1 week, which is the probability of the units.
After we have found the probability, we can apply it to our binomial distribution formula. We let R be the number of weeks with average daily revenue between 8,500 and 12,000 out of 4 weeks. From the question, we have to find that when R is 2, what is the probability? As R follow binomial with n equals to 4 and the probability equals to 0.97208. As a result, the required probability equals to 4C2 times 0.9208 square times 1 minus 0.97208 square, which is equals to 0.0044. And this is the end of our presentation. Thank you.